Hello.
Hello.
Hey, everyone.
Hope everyone's doing all right during this pandemic. Hopefully everything's all good.
Yeah. What's the new thing that I hope you're staying positive and testing negative? I've gotten that on like 8 different emails this week.
Oh, that's great. Awesome.
Yeah, also everyone have enjoying good moves, good food, and be prepared that vaccine is arriving. That ease life is gonna finish.
Hopefully we'll be getting it soon. Yep. The vaccine, not COVID. Awesome. So welcome to Chrome Dev Summit Extended for GDG UK and Ireland.
Yeah. Shall we get into it?
Yeah.
Yeah.
Let's go.
It's cool. Felt like it had kind of a 90s vibe to that opening. I like it. So we're going to be your hosts for today. I'm Erica. I'm a GDG from Glasgow. We've got Leo. You want to introduce yourself?
Hey, I'm Leo. I'm from Dublin. Actually, I'm a part Brazilian here, but I'm representing Dublin.
Hello, my name is Karthik, and I'm from GDG Southampton, but currently at Reading.
So we're keeping it interesting around here. Right, so some really quick housekeeping tips. So we're going to have 3 sessions. We have 2 tracks, 1 and 2. You're currently on track 2. So we are going to have 2 sessions on track 2, and then for the third track, or for the third session, sorry, you can pop back over to track 1, and we'll have the link up for you whenever you're ready. If you have any questions, pop them in the YouTube chat, and we'll keep an eye on them. If you're interested in our code of conduct, we have a link here. You can check it out, ask any questions. For social media, we do have a couple of hashtags we'd love for you guys to use, but please let us know what you think. Let us know how we're doing, and please ask us to do lots and lots more of these because they're fun. And we do have prizes. So there's a form for you to fill out. You will be entered to win a Google Home Mini. Those are awesome. So yeah. So we've got 3 presentations going on today. Like I said, just to remind you, the third presentation will be on track 1. So you're just going to have to click the link, pop back over there. Should take 2 seconds. So our first presentation is Saurabh Rajpal. He's going to be presenting on caring for web with Vigor. We're going to have a couple minutes for some Q&A afterwards. So as questions pop up, just let us know. And our second is going to be Video Killed My Data Plan by Doug Sillars. So we're looking forward to that. We're getting a very strong like pun vibe from these guys. So I'm actually really hopeful that we get some like grade A quality. Like I'm hoping for dad jokes, but I'm just always hoping for dad jokes. Yeah, and then we'll be wrapping up with Paul Kinlan on Chrome and the web in 2021 and onwards. So hopefully we'll end on a super positive note. Yeah.
Awesome. So first up, we have Saurabh. I'll just add him to the stream. Hi, Saurabh. How are you? You muted. Sorry.
That just sucked the entire energy out of me. I was like, hey, guys, I'm so excited to be here. And I was like, you're on mute. Wow.
Don't worry, I've done that tons of times.
Those things happen.
It always happens, right? On the day of the event, it always happens.
Yeah.
It's okay. So we can feel it from you, though.
Yeah. How are you doing?
I'm doing great, and I'm feeling so excited to like come and present this talk today in front of the UK and Ireland audience. And can't wait to see what kind of questions they have, what kind of things they would like to ask me at the end of it. I hope it stays within the limits of the topic, but yeah, I'm pretty much open to answer anything and everything which is within the boundaries of answering. I mean.
Awesome.
So no like life, the universe, and everything kind of questions.
Let's see. It's pretty chilly and pretty late here. How's the weather there in your area?
We're all split up. For me, it's been raining the whole day. It's not been great, but it's all right.
Yeah, pretty much the same here in Glasgow, but that's virtually always true. So
Yeah,
you've been with Google for 3 years, is that right?
Almost like 1 or 2 months less, but yeah, almost 3 years.
Awesome.
And you kind of described yourself as more of a generalist than a specialist?
I kind of like to be a generalist. That's the kind of flavor that I've had in my entire journey here so far. So to give you a glimpse of how my career has shaped up, I started off as a web developer. I moved into the app world because that's the cool thing that was happening at that point of time. Everybody was becoming an Android developer, iOS developer, blah blah developer kind of a thing. So I just moved my world there. Then I thought I should become or like hone my skills to become more of a full stack. So I need to learn the back end. I moved to back end, started developing micro services, getting into the APIs and all those things into the Java world. And then cloud became hot. So I was like, okay, that's the way to go. And I started learning cloud and only to land myself into Google as a web consultant, after so many years of doing the full stack work. I think what has really helped me is being this kind of a generalist, being understanding how to connect the dots right from end to end. And when I do this kind of a consultative role right now at Google, it really helps me understand things at a much broader, uh, with much broader perspective. So I think that's pretty much about it. It's a personal choice. I don't like to stick around on one thing. It's a personal choice, and it has worked for me. It might or might not work for you, so a caution there.
Awesome.
Nice. Day after day, I have seen the importance of DevOps getting on more effective on the developer's life. Yeah, it's nice to hear it from you.
Well,
Cool.
one size doesn't fit all, and I've heard so many different stories where being a generalist could backfire as well, and so could be a specialist, right? You are stuck in a technology which no more exists, and you can't look at life beyond that, for example. So it becomes a troublesome area that way as well.
Yeah, it does seem like you have to be kind of constantly growing and learning in this industry. I mean,
Always. I think one of the things that my parents used to tell me is don't choose the line of doctor because they have to keep themselves up to date with the latest medicine and stuff like that. And like 30 years down the line, I'm telling my mom, hey mom, even we need to stay up to date. So why didn't you tell me about this stream earlier?
Great.
so did you immediately get sucked into the role of family IT person?
uh, well, yes, in short.
It's a universal experience. Like the moment I proved that I knew how to turn on a computer, I was getting calls from my grandmother.
I software engineering IT is a different world altogether. You just can't keep yourself off the screen, be it the big one or the smaller one, right? So
Yeah. Awesome. So I'm going to assume you have a lot packed into your talk today. So we will let you get started. Sounds good?
awesome. Yeah, sounds good to me. Let's hit the road.
Cool. Sharing your slides now.
Okay. Cool. So we have a lot of people here, I'm assuming, and then very quickly, in case you are just joining into the stream, hi, I'm Saurabh Rajpal. I work as a web. Sorry, are we live? Okay, cool. Sorry about that. Cool. No worries. So hi guys, I'm Saurabh Rajpal. I work as a web ecosystem consultant at Google. Now, being a pool of web consultants across the globe, our team sits very comfortably in the middle of product and customers for Google. We work very closely with the product teams to evangelize the product adoption that the teams are building and also enhance them based on the customer or user feedback that we receive while working with some of the top and strategic partners from our respective regions. I'm super excited to join you all today to take a step forward in caring for web with vigor, the same vigor with which we have all come out of our daily routines and are attending this brilliant CDS extended event organized by GDG London and Ireland. So there are just 3 easy steps I'm going to share today to do this. And that is knowing why, what, and how of core web vitals. I'll try to cover each of these aspects in as much detail as I can within the 30-minute slot that I have got today. But in case of any doubts, we do have some time for Q&A at the end. And in case we fall short of time there too, I'm usually very responsive over my social handles. You can connect with me over the ID I am Saurabh Rajpal. I do want to emphasize on usually very responsive. Don't kill me if I'm late to answer your queries. And I usually don't answer the question how to get into Google because I wouldn't have believed the person saying just by good luck as the answer myself. Then on that note, let's first look at the why part of it. That is, why should you even care for caring for web? Wow, that was almost a tongue twister. Care for caring for web. Anyway, the answer to that is let's get first real. So often when we're ordering pizza, looking at those fancy TV commercials, we believe this is how it's gonna be. Well, that's certainly the expectation even when I'm baking one myself. But in reality, when it's delivered or baked, doesn't it turn out to be like this? At least that's the case in India. Sorry for bringing my personal experiences into play here, but what I'm trying to convey is when I visit a website, I have a certain expectation from the site. I want content that is useful and interactions which are smooth and predictable. On the contrary, this is what I get. And to be fair, site owners and developers do try different UI patterns and meet the customer expectations while also balancing business needs. The big question is, what really makes for a good user experience? Well, there is no right answer to that question because user experience is different for everyone. But we could at least try to ensure as much as possible that the site doesn't take too much time to load, doesn't take forever to respond to the interactions that the user is making, and doesn't keep jumping around with too many layout shifts. I personally find the third one to be the most annoying, especially with clicking of random ads while attempting to click a useful link of my choice. Well, to some, this might still be a source of entertainment by being engaged while landing onto some random pages and carrying on with the random content. But let's be realistic. Not everything in the world is YouTube. Well, if you're still from a category of developers who don't really care for the user experience on your website, just like this chap, then I have a couple of strong reasons which should matter to you. And that is, after research of millions of pages, we found that if a site meets the core web vitals threshold, users are 24% less likely to abandon the page before the first content is painted. And even if this isn't a convincing enough reason for you to still be convinced to meet core web vitals, then my friend, you should know this latest update from the Google search team as well, which is like last month itself, they announced that they have the intent to incorporate core web vitals into their process for measuring web page performance experience benchmark. And this is becoming a reality in just over the next 6 months. For developers who value discovery via Google search or organic traffic, as they commonly say, this provides an extra incentive to improve their vitals. Now that I have anyway brought up this topic, let's take a sneak peek into the world of core web vitals in SEO. But before that, let's understand what SEO actually means. By full form, it does mean search engine optimization. But according to Wikipedia, it is the process of improving the quality and quantity of website traffic to a website or a web page from search engines. SEO basically targets the unpaid traffic, known as the natural or organic results. We have heard that Google is pretty good at figuring websites out, and it's tempting to assume that having a clean website means you don't need to think about the SEO. But it's not that simple. Let's first understand what really goes behind it and also the art of metrics gathering, which is particularly important from Core Web Vitals perspective. So when it comes to the data sources, we differentiate between the field data and the lab test data. Field data, also called the real user monitoring or RUM data, is collected from users over the course of about a month, and it's based on what they experience when viewing your site. This is part of the Chrome User Experience Report, or in short, CRUX as we famously called it. Lab tests, on the other hand, are generated on demand with testing tools in your browser or on a server using settings that try to approximate what the users would be seeing. So for search rankings, we use field data, as this is what your site's users would have experienced over the time. This makes the data more representative for your site, taking into account where your users are located and how they access your website. So just to put things into perspective, a site which basically is being run in India, for example, where usually the users are coming from, say, low end, like accessing a website over the low end devices, or they're coming through an area which is like having lower bandwidth. It might be the case that your user experience report or the RUM data shows you really drastic difference as opposed to say somebody running the website in UK, which is known for having high-end devices and for fast internet. So that's why the field data becomes really important. And just by saying that you could achieve a score of say 100 or a real perfect score in the lab doesn't make sense a lot. While of course, if you are achieving that, it would mean that your users are experiencing your website in a very good way. But it's always good to have a sense of the real users that you have, from the kind of places they're coming from, the kind of devices they're accessing your website from, and how they're experiencing your website actually. So the Cwv Vital metrics are then combined with other signals for search. We call this combination the page experience ranking factor. The additional signals are mobile friendliness, safe browsing, HTTPS security, and compliance with our intrusive interstitial guidelines. These have been around for a while, and there's much written up about them already. So I don't want to go into details here. We plan to adjust these signals over time to best reflect a good user experience for users. And that's why Google is giving you 6 months. So the data, if I talk about the split, it is generally split by mobile and desktop, and it's applied appropriately for search ranking. It isn't the case that irrespective of whether you have more number of users coming in from mobile or desktop, the search ranking on the respective devices would be impacted. But it's more about how the split is done. So for example, when the mobile page is shown as a separate AMP URL to users, that's what will be used then. In other words, if you're on a mobile page, the ranking is only affected by mobile data, and the same for desktop. So in short, for search rankings, we use the page experience set of metrics. These include a few existing signals as well as the core web vitals. We track these based on what users would see, separating mobile and desktop experiences. Well, to be very honest, I'm not at all an SEO expert. But if you want to understand more about this area and the way CWV could could really be your friend, do check out this brilliant 10 minutes talk from John Mueller himself, available on Chrome's official YouTube channel. I would highly recommend you to go through this. Now that was the why part. Let's come on to the what part of it. Well, if you're also like this, like we also like this Sparta at the moment, it could potentially be due to my different accent. But let me give the benefit of doubt to myself and benefit of doubt to your lack of understanding of this topic. So let me cover the CWV metrics for you real quick. First of all, we talk about, if you go back a few slides, I told you about making sure that your site is loading as quickly as possible. And one of the key metrics in Core Web Vital is largest contentful paint, or LCP as we call it, right? Now this metric, what it does, it indicates that what is the largest content that is getting painted on the user's website, on the website when the user is accessing it. And just to give you an understanding of it, imagine if you have two sections on your first fold. Like when I talk about a mobile, we talk about folds. So whatever is coming in the first above the fold, right? If you have an interstitial which is getting loaded at the end, then that would be your largest contentful paint. And that could be a really bad experience for the user. Plus, it would really push your website to be ranked really bad. or like at least given the score really bad. So take care of this thing. Second is the FID, which is the first input delay, which is with respect to the interactivity. Now, one important thing to note here is that first input delay can only and only be captured in the real world. It can't be, what do you say, it can't be understood in the lab directly. Now, because the reason for that is it reflects the time it takes to respond to a user interaction. And there are tons of different type of users that you might have. Some might click on the website as soon as they click on the website URL. Some people might click on it maybe after a lot of time when the site has taken enough time to load. And there could be different point of delays that the different users might face. So in order to replicate or understand this in a lab setup, what you should really be caring about is the total blocking time, or the blocking time that your website is going through because of, say, JavaScript or any other kind of render blocking resources that you're using on your website. Now, just imagine if you reduce these blocking times in such a way that they're in such small sections, the chances that the user is clicking through those empty gaps becomes more, right? And then you have higher chances of reducing your FID. So in a nutshell, what I want to say is FID is something which is only measured in like real user, a real world, but you could still work around with it by taking care of the total blocking time. The third one is the cumulative layout shift, and this is with respect to a lot more about the visual stability. It does talk about the content which keeps shifting. In the real world, we have all seen some random ads being inserted. We have seen footer being dropped down because of the insertion of some random content as you're scrolling and stuff like that. So I think all of these things lead to a poor user experience, as we are all aware, and this score also gets impacted because of that. Now we have covered the why and what. I hope by now you're already clear on why exactly it should matter to you and what are these metrics really. So now let's talk about the how part. And this is the last part that I want to cover. But in this section, there are two things that you should like worry about. First thing is how to measure, and then followed by how to improve. Because if you can't measure anything, you can't improve it, right? But here are some tips to do for you to do that. Now, first, I want to speak about how to measure, and here are all of the tools to support you as you measure, track, and improve. And yes, there are tons of them. So what you see on this slide are PageSpeed Insights, Chrome UX Report, Search Console, Chrome DevTools, Lighthouse, and Web Vitals extension. Well, I could go deep into all these, but this is a summary view of what is available where. Now, as I talked, that FID is only available in the real user world. It's not available in the lab. This should give you a signal that uh, wherever you're seeing those ticks under the FID column, those are the tools which does capture the real user metrics as well to some extent. For example, PageSpeed Insights does have a RUM section in it. Chrome UX Report, Crux, as you said, is totally based on RUM. Search Console also reflects from your real user data. DevTools, since it's more about running the Lighthouse within DevTools and running those traces within DevTools, it's not about the first input delay. It's basically the total blocking time, as I mentioned earlier, and you could figure out how you could enhance those. Lighthouse, again, similar like Lab. And Web Vitals extension is a brilliant source which people can use to get a sense of how exactly the core Web Vital matrices are getting impacted when you actually visit their website. So the Vital extension would show you then and there what are the metric scores you're getting while visiting the website. And then there are a lot of RUM and analytics providers ecosystem which has moved real quickly. So Core Web Vital is now available to you if you use Cloudflare, New Relic, Impulse, SpeedCurve, Calibre, and like much more. This whole performance metrics ecosystem is like moving really quickly, and these are some sources of like brilliant ways of capturing the real user metrics, as I mentioned. Well, we can't keep Google Analytics behind, right? Because it's also a fact that many sites do currently use Google Analytics. And that's why they want to be able to measure Web Vitals in the tool they already use. So last summer, the Chrome team released the Web Vitals JavaScript library that we just saw, which was part of that extension as well. And along with the instructions on how to collect Web Vitals data and send it to Google Analytics. So at CTS this year, they've launched the Web Vitals report, an open source website and tool which lets you query and visualize your Web Vitals in the Google Analytics itself. This report also allows you to compare data across segments, so you could see how much performance affects your business. Cool. So we've looked at the page experience, we looked at core Web Vitals, and we have also looked at how they're used in search. Let's take a look at the Search Console now, which is generally the go-to tool for almost all of the website owners. Search Console is a free tool for site owners that gives insights into Google search for your website. I'm sure you have probably would have already encountered this, but once you have the verified ownership and given the tool a bit of a time to collect these metrics, you could directly go to the CWV Vitals report. So in this report, for example, if we go a bit deeper, you will see graphs for both mobile and desktop, showing how a relevant sample of your sites, in the pages within your site actually score. The sample and the scoring is based on the Chrome User Experience Report, or the CRUX report, as I mentioned earlier, which is the field data collected over the time. And because of that, any changes you make on your website will take about a month or so to be reflected there, because the CRUX data is generally based on the 30 days of data, about a month's data. So clicking through one of these URLs, you would see a graph of total number of URLs tracked. And you can see the individual issues flagged just right below it. So going to one of the issues, you will see a similar graph on top, together with a list of sample URLs for that issue type below. So keep in mind that these reports are based on the field data. Not all of your website's URLs will be available here. It's often useful to focus on the higher buckets of issues across both the poor and the needs improvement category. We try to recognize patterns such as shared templates and group all those URLs together, as fixing these issues once can improve larger parts of a website, which is awesome. So it's more like fix once, use everywhere. So a good approach generally is to try improving these issues by digging more into a bigger issue type and work to resolve it. So after recognizing the issue, the first step is usually trying to reproduce the issue locally or within a testing tool. If that's not possible, for bigger issues, it's worth narrowing things down using the various tools and scripts available elsewhere. Once you have reproduced the issue, you can work to improve the vitals. I won't go into the details here, but be sure to check out the other sessions for more information, which are available on the Chrome's official YouTube channel. As an aside, sometimes you may notice that other Google products or services are slowing down your pages. Google search doesn't give any special treatment to these, just like users generally don't care why your pages offer you a bad user experience. Treat embeds from Google just like you would for any other embedded resources. Once your live website is updated, you can tell Search Console that the issue is fixed. And this is done in the appropriate drill down report that we saw before by clicking the Validate Fix button on the top. Search Console will then start a review of the URLs flagged and let you know how your improvements turned over the time. So now let's look around how you already figured out how do you measure it. Now let's look at how can you improve these things, or the three metrics that we're talking about here. So first is improving the LCP. I'm not too sure how familiar you guys all are with respect to the different type of metrics that you see, or different kind of reporting that you see in the Chrome DevTools or Lighthouse. But for improving LCP, think of it this way: it's the largest contentful paint that needs to go in, right, into the website as soon as a user is visiting. So first thing is you should reduce the server response time. Now, ideal way to do this is via usage of CDNs, right, which which are the content delivery networks. And as they localize the content, it acts as your kind of a cache, which could really deliver your content real fast to the users locally. But sometimes, even when you're using CDNs, people still face a high response from the server time, response time from server. If that's the problem that you're facing, try to understand if your server side rendering your pages, if there is any heavy SQL query that's stuck, that's taking a lot of time, which is not optimized, and making your web page processing to be slower till the time it is sent out. So ensure that you're reducing the server response time so that at least the content that is received by the browser is able to paint, right? Second is the render blocking resources. So JavaScript, CSS, fonts, these are all render blocking resources. By render blocking, we mean these resources need some time to be processed. And while they are doing so, they could really jank up the main thread, right? Now, in order to fix these things, there are a lot of ways we could figure out the excess of JS and the excess of CSS that you already have. By excess, I mean the JS and the CSS which is not directly used onto your website at the very moment it's loaded. It could be a JavaScript file which is so heavy used across your pages, but you're loading it upfront. So avoid doing this. Chunk it off into pieces. Just deliver the JS and CSS which matters to you for your paint at that very moment, and then defer loading them later on, right? Third one is the reducing the load content time. And a lot of times we see a lot of websites are image heavy. And since you're loading so many images for the entire pages at times without even realizing that why should a user wait for things to load which doesn't even matter to them at that very instant. You should then try to defer these like image loading later on when the user is scrolling up, or to even make it better, you should always enhance or optimize the images that you're using. There are tons of resources which are available, which guides you around this space. There is a amazing website by guide by Addy as well at images.guide. There's a Scoosh app which was developed by some of the cool DevRel team members, which lets you like convert your images into an optimized format, which is more progressive. So you could do all those things as well. Cool. Now coming and talking about the total blocking time and FID. So I think the major issue that you see here is the jankiness or the blocking that the main thread, which processes your JavaScript, which processes your all the content that you're downloading while painting your website, uh, it goes through, right? So in order to avoid these input delays, you should focus on creating or delivering your JavaScript and other resources in such a way that the main thread is not blocked for more than 50 milliseconds in one go anytime at any point of time. So for example, just giving you an example is, if you load a very heavy JavaScript file, right, and it takes time to download, it takes time to render, it takes time to process, it going through all those phases, right, it can really block the main thread for a longer period of time. Now just imagine if you would have just chucked these off into separate chunks, it would have taken much lesser time to not only download but also to be like get processed, right? And if you could manage these uh, chunking in such a way that each of these resources are taking less than 50 milliseconds of the main thread's time, then you are into getting yourself into a situation where, irrespective of at what point of time the user clicks your website, they most probably would have clicked at a time when the main thread was relatively free. It wasn't really busy processing your JavaScript or any other kind of uh, like resource. And the uh, the input, there was no input delay. Basically, it was interactive at that very instant. A lot of times people also suffer this. A lot of people who are using third party code, it could either be for tracking, it could either be for serving ads, it could either be for tons of other things. A lot of time these third party code as well takes a lot of blocking time for your main thread, and this is when we don't even realize that such a small inclusion, like inclusion of a third party, which is in such a small size, could really make such a difference. The reason for that is sometimes the third party libraries that we're using, they are nothing but just bundles of resources that they also want to download externally. So sometimes when we include these third party scripts thinking that it's such a lightweight, eventually you would see that there is a separate waterfall of requests which comes out of it, because of which uh, your waterfall becomes large, the waterfall of requests become large, and it blocks the main thread, and you encounter a lot of like input delays from the user. So you have higher TBT, which in a way impacts your performance score and your user experience eventually. So just take care and think about these before using these third-party libraries. Think how you could figure out which of these libraries are really impacting the user experience, really impacting your website score, and try to find some alternatives, or at least try to figure out if you could get them improved in terms of deferring few of the resources and stuff like that. General practices that we've talked about. Okay, and third one is the cumulative layout shift. So in the cumulative layout shifts, I think the best way to do this is to understand your structure of your page really well in advance. Now, for example, if you go back to the beginning of the slides that I presented, I talked about what I expect versus what I get, right? And in what I get, I showed there are tons of other layers that usually website owners put in. Now, you being the owner of a website should really know that what kind of ad would I be serving at the top, for example, what kind of content I need, and what's the width and height of the content that I need there, be it an image, be it a separate div, or something like that. So you understanding that bit should predefine the spaces for these rather than surprising the user with some random shifts. And there are tons of good practices that you could follow in order to getting into these pitfalls. Now a lot of time people ask question that I do want to serve my ad, and uh, if I just put a slot for ad, and what if the ad doesn't get fulfilled? It would look bad if it's empty. You're absolutely right. But then just imagine that if that ad, it shifts the entire content downwards, it's a wastage of the painting resource as well, right? Just imagine you have to paint a wall, you have to design a cartoon on it, and just imagine if there is a need for another paint just above it, you would have to repaint the entire wall again, which is such a costly affair. Similar to that, when the web page is painted, you need to tell the browser that this is the spaces that I need to dedicate for these slots, and I won't need to repaint these anyway. So it improves your performance numbers, it improves the user experience as well. Also, if we talk about the fonts, there is a font display optional feature, which a font display feature which you could use, which what it does, it instead of waiting for fonts, it directly like it paints the font onto the page and takes care of it when it's available, and it avoids the content shift as well. So in summary, these are the three key takeaways that I would want to share with you. First, do not insert content above existing content unless it is in response to user interaction. Provide a smooth and predictable experience. Second, if content needs to shift in response to a user interaction, do so immediately. Don't wait for a network request to finish. For requests that might take more than 500 milliseconds to complete, use placeholders to reserve space as the content loads. And this even includes the ads that I mentioned earlier. So for all the interactive elements on the page, ensure that if it looks interactive, it actually is interactive, because otherwise it would add up to your input delays. So if you're using, for example, a server-side rendering, consider rendering your pages in a loading or disabled state, and then updating them to look interactive only after hydration, right? If at the beginning I do paint this button just so that my LCP is good, but I don't make it interactive and I'm waiting for some JavaScript to load, it would all lead to the total blocking time, right? So I think if you want to learn more about these good patterns or the UX practices that you should do for improving your core web vitals, there's a brilliant talk by one of my colleagues in the Chrome Dev Summit. You could go and check this out. And even for input delay, there is a detailed thing that has been shared by Chenny and Damien. Again, some of my team members who have gone into the much detail about what really causes first input delay in practice and how could you avoid it. They also talk about some of the one of the partners who have done this so beautifully. And one bonus tip for you guys is Adi Osmani, as you probably would already know him, just released a new material in ebook format, which is covering different aspects of core web vital optimizations. One of my teammates had chance to contribute to one chapter as well and review the content. And he actually found it very handy, especially for those uh, who prefer reading books rather than many individual blog posts. The content is mostly based on the existing web.dev articles itself. So if you have already read through them, you probably could skip this. But if you're not the blog person kind of a thing, you could actually download this uh, free ebook. And with that, I come to the end of my session. Thanks a lot for hearing this out patiently. I do hope uh, you're taking back some learnings from this session at least, and I'm open for any Q&A.
Awesome. Thank you so much for that interesting talk. Do we have any questions?
Yes, I have indeed. Saurabh, how do you see those modern server-rendered JavaScript framework being used in order to have a better application performance? And if you compare the learning curve and the time of the development and the real improvement, is this still being a worth stuff to do?
Well, to be very honest, I can't really advocate about a particular framework in particular. All I can say is that each of the frameworks do try their best to make sure that they are not really putting the developers into a situation where the sites are slow, right? Nobody wants to say that Angular website is slow. Nobody wants to say the same for React and stuff like that. But I do see that if you as a developer do understand the framework in a very nice way, you do understand the kind of capabilities that these modern frameworks provide, you could definitely achieve all of these metrics very easily. Now, for example, if you're using React, and by quoting React, I do not intend to say it's a good or bad framework. All I want to say is if you're using React, there are ways that you could use a hybrid way of rendering, right? Rather than uh, like just putting everything onto the browser to load on the client side rendering, or rather than putting everything on the server to load, which could lead to different kind of matrices being impacted. Now, for example, if you're doing everything on server side, you could take a larger time to completely load. Lesser time to completely load, but larger time to deliver it. And on the flip side, on the client side, it might take ever, right? So forever to hydrate all the elements that you have. So I think striking the right balance, understanding the kind of features that they provide is the right way to go about it, rather than cribbing always about this framework is better than the other framework, that is better this. That's my answer.
Yeah, cool. Perfect. Thank you very much.
No more questions?
I don't believe so.
Awesome.
Thank you so much for giving the talk, Saurabh. It was very nice having you on.
Same here.
I definitely
Thanks a lot, guys,
appreciate
for having me.
Cool. So next up, we've got Doug. I will let Erica introduce Doug.
So before I introduce Doug, just a quick reminder that we did put up the link to the Dev Party raffle. So make sure you fill that out. We are giving away prizes.
Hi,
I think, Doug, you can fill it out too if you want.
Awesome. I'll do that. I have to find it.
We can send you the link.
Awesome.
So, Doug, you're a leading mobile performance developer advocate.
Yeah.
Right? That's cool. Not actually sure what that means. It sounds very cool.
So it's trying to fit a whole bunch of stuff in just a few words. So I do a lot of performance work, and a lot of it surrounding video and images. So I'm going to talk about video tonight. And so I do a lot, and I do a lot of developer relations. So right now I'm actually working for a company that has a video API. So I'm trying to promote, obviously, that people should use that API to serve their video, and the reasons why. So we'll talk about why video is so important on the web today, and then also why you should care to do it well.
Awesome.
Very helpful.
Nice.
We won't slow you down. Get ready for it.
All right, I'll share my screen here.
Yeah, go for it.
And all right, share that one. And then we sort of have the inception look here for a second. All right. And I always want to click the share button when I'm in Google Slides. I don't know what that's about, but like it's like yellow, and so I want to press that one. So the title of the talk is "Video Killed My Data Plan," and the reason for that obviously is you're building a web page, you're building an app, you've got your JavaScript, you've got your CSS, you've got your HTML, you have your images, and images obviously are big. And then you start thinking about adding video, and video is like, an order of magnitude larger than any image you're going to put on the web page. And so, there's a lot of information out there about how to optimize images for the web. You can use Lighthouse, and there's 3 or 4 tests in Lighthouse to say, you're not optimizing your images. You could do a lot better job at that. But there's not really a lot out there to help people figure out how to put video on the web. And so that's sort of where we're fitting in here today. So I'm Doug. I'm running developer relations at a company called API.video. I do a lot of performance audits, web native. I wrote a book on Android, like Android M, Marshmallow. So it's kind of old, but if you want to download it, that's the URL. And I always try to put my mouse there, but then the slides thing always pops up. And then if you ever want to reach out, I'm the only Doug Sillars on the internet, so I'm kind of easy to find. So what are we going to talk about when we talk about video? I'm going to talk about video on demand today. And so video on demand is, recorded video that we're going to play back. I'd love to talk about live video, but I just don't have enough time, right? I mean, I'm not here all day, and you guys want to do other things tonight. So video on demand, short play videos. So, looping videos, this is like the MP4 that you put on the web page. I'm also going to talk a little bit about streaming and why we should think about doing HLS or Dash video on our web page. And also what HLS and Dash is, if you've never heard of those. So short play videos, your background videos, the hero video, maybe something looping at the top of the page, maybe a short informational video, right? Click here to learn more, and a video plays. And so, as I mentioned, videos are really, really big files. If we look, this is from April of this year, but if you look at these are mobile web pages, just the size in kilobytes, right? The median, mobile web page is like 2 megabytes. So anytime you load a page on your phone, you're probably eating about 2 megabytes of your data plan. You start talking about the median mobile web page with a video, and it's 5 megabytes. Right? As soon as you start adding video to a web page, the page is just bigger, and it's impacting both load time, it's impacting your customers' data plans, all of those sorts of things. The median site with video is 250% larger than the median website, and the median web page with video is 25% video. You come out here and you see these web pages that it's just like there's a little bit of CSS, there's a little bit of JavaScript, and then there's just like this video file that's just huge. When it comes to performance, browsers are generally really smart. And so this is a screenshot from Web Page Test. And this is a waterfall. So these are all the files being downloaded. And the video is here in green. These purples are images, right? They take a little bit longer to download because they're bigger files typically than the text files we use for everything else. And the browser knows, like, well, video is going to be big. I don't want to impact the CSS, the JavaScript, the images, all that other stuff. We'll just download it at the end. But what does that have to do? Let's talk about video user experience. First off, the video tag. So this is supported in all browsers, I think, except for Opera Mini. So this works just about everywhere. You can add video tag. You add a source and the video. This sometimes works. We're going to want to add a lot of attributes to really customize the way the video shows up on your page. Video autoplay, source equals. So the autoplay attribute autoplays the video. This sometimes works. Every single browser has a different metric to decide whether the video will autoplay. And a lot of it is, has the user been to this web page before and pressed play on a video? And so if you do that, then the video next time you come might autoplay. And each browser is slightly different as to how many times you have to visit, how many videos you have to play before that happens. This makes it really hard to test. Because obviously if you're testing your own web page and you press play on a couple of videos, now all the videos autoplay. And right, so it's hard to see what the user experience is for someone who's never been to your web page before. This also will not work on mobile, which is really, really important. Now it will work on mobile. For mobile Safari and mobile Chrome, you have to have the muted attribute for video to autoplay. And my theory here is that the Chrome engineers are all in meetings, just like we are, right? And there's sometimes where you're really bored. And the last thing you want to have happen is, people to realize that you're surfing the web. So the videos have to be muted. You can add control. So this is the bar at the bottom, right? With the play, pause, and you can see, how far along in the video you are. If you don't add the controls, this could be, a background video that you don't want people to be able to start and stop. But now they can start and stop it. You can set width, you can set height, just like you can with an image. You can set a poster. And so the idea with a poster is if you don't set an image to display instead of the video, it'll show the first frame of the video. Or it'll pick a frame of the video. And sometimes that's a really great frame, but sometimes it's like weird. And so this way you can choose exactly what is going to show up to your users. By default, you can just pick an image. If you set a loop attribute, so this video is going to autoplay even on mobile because it's muted, and it'll loop. And so now you've created sort of an animated GIF. And actually, this is a better way to serve a GIF than actually to use a GIF itself, because GIFs are really large files. And an animated GIF, if you have 15 frames per second in your animated GIF, it's literally 15 GIFs every second cycling through. And so a video has better compression. And so this is actually a faster way to deliver looping GIF type images. And if you look at any website that has GIFs, like Slack or Twitter or any of those, they actually use looping videos. So you should as well. Another attribute in the video HTML5 video tag is the preload attribute. And you can set preload equals none. And when you do that, you're telling the browser, hey, I've got a video, but don't download any of the video until they press play. And so if you look in Safari, this is a web page that's 200 bytes, and you can see none of the video is downloaded. The default attribute is metadata. And what metadata does is it tells the browser, hey, download a little bit so you know the size of the video, the dimensions of the video, and maybe the length of it. You can get some of the metadata so you can populate the page a little bit better. And so now this page is 620K, same exact page. I just changed the preload value. Preload equals auto is a great attribute as well. And what that does is it tells the browser, hey, just download the whole video. They're probably going to watch it anyway. And in this case, in mobile, in Safari, you can see it download 31 megabytes, right? So there's a little bit of a leap here between metadata and auto. And auto is really powerful, but it also uses a whole slew of data, both from your server, so it's costing you and your company money, and also your customers, right? You're blowing through 30.5 megabytes more data than you were with the metadata. So use preload equals auto if you're like 90% sure, or if you're sure that 90% of your users are actually going to watch the video. you can set for multiple sources. So you can, here's a video autoplaying with the width, and you can set multiple sources. And what the browser does, just like if you're using a picture tag, the browser will pick the first one it knows what to do with. So if you're in a browser that knows what a WebM video is, it'll play this one. If not, it'll fall back to the MP4. And if you're on Opera Mini, you'll get the message your browser does not support video. Now, you can see here, I've got different sources for different formats. When you're dealing with images, you've got this whole idea of media queries where you can say, you know, for a certain size screen, serve the big movie, big image, smaller screen, serve the smaller image, right? This is the idea of responsive images. That doesn't exist for videos. So unfortunately, or fortunately, there are other solutions. We can go to a streaming video solution to serve different size videos for different size screens, right? And that makes sense. You don't want to serve a 4K video to a mobile phone, right? You want to serve a smaller size version. You can use JavaScript to insert the different sources if you wanted to, but we're going to talk about how streaming video is the right solution for this a little bit later in the talk. I want to run through a couple examples of web pages that do really funky things with the video tag. The first one is for a building in New York. It's run by a guy who used to have a TV show. And it has a background video. And I think I have the page open here. Right, so there's this video playing in the background, right? All right, so what's interesting about this page is this is the HTML for the video, and it's inside a div. This is the video container. And what the developer did here is they have a video for the desktop video, right? Muted autoplay loop, plays in line, Trump Tower the experience. Then there's a second video tag that says mobile video, and it's Trump Tower the experience mobile. So the problem here is instead of serving one video tag and deciding which video to play, they just serve both, right? So mobile users get 20 megabytes of video, desktop users get 20 megabytes of video. The desktop viewers will see the 13 megabyte one. The mobile users will see the 6.6 megabyte one. Like, that's sort of ridiculous. In this case, it's actually worse to have. It's actually worse to have the mobile video here. It'd be better just to serve the big video to both people, and then you'd save 6 megabytes per page load. Second example here is, again, we've got a div. We've got a video that loops. It's muted and it autoplays. So this is a looping video, background.mp4. But what they have here is they have a poster. And so this video is, as soon as it starts downloading, is going to autoplay. And so you actually never, ever, ever see this first frame.jpg poster. And in the case of this web page, that first frame JPEG was 250K, right? So they just wasted 250K. It's an image that nobody ever sees because the video just goes straight to autoplay. So if you're going to autoplay a video, you probably don't need a poster because the video is just going to autoplay. Third example is climbiowa.com. And this is not a, so I should say none of these are digs on the, or placing blame on any of these web pages. Like this example here that I'm going to show you is so prevalent on mobile web pages. It's probably the biggest issue that people have when they're dealing with video on mobile devices. And so I have that page open here as well. All right, so I loaded the page, masks are required. They've got a background video, right? So this is the web page, right? But you can see here in my Chrome DevTools, I've downloaded a small MP4, and it was 4.2 megabytes. Anyone see the video? You don't. And the reason you don't see the video is we can come. Let's see if I can find it really quickly here. All right. Main. Hero. hero top video. Let's look at this video tag. Let's look at their CSS. Display none. So what they've decided here is if the screen is a certain size, we shouldn't show the video, right? If I make the screen bigger, all of a sudden we've got the video. I make the screen smaller, video goes away. This is like the biggest thing that happens, the biggest issue that I see with mobile web pages today is that, you know, we've got this 4.3. So when I widened it out, more of the video downloaded, right? The full video is 7.2 megabytes. But the biggest issue I see when it comes to the mobile web is they put the video and they say display none for small screens. And what's important here is when the browser sees the video tag, it starts downloading the video. And then the CSS is applied after everything starts downloading. So display none does not mean download none. And so every single person who goes to that web page I just showed you, or a plethora of other sites, like, you know, probably a third to a half of the websites that have video on the desktop hide it on mobile. And they do it like this. And so this is the wrong way to do it because you end up just sending video down to people who will never, ever actually ever see it. Fourth example, this is just a video on the page. But what's interesting here is they have controls. They set preload equals auto. And if you look, it's a 90-second video. It's 88 megabytes. And they're forcing the browser to download as much of it as it can. And, you know, I'm one of those people where I go to a web page, I'm on my phone. I don't watch the videos most of the time, right? In this case, my phone gave up after 61 megabytes. You know, if you're on a limited data plan, that's really expensive. You didn't want to download 61 megabytes of that video. You weren't planning to watch that video, but the developer has decided that you get it. The last example, I forgot to open this one. It's not really a great example for a for all of us to see here. But what you can see here is that there's this full screen background video. And, you know, again, you can't really tell, but this video has an audio track. And there's no way for you to hear the audio track, right? It's just, you know, the audio is being downloaded and not being played. And so, go back to present. Again, like if your video is going to be in the background and it is going to be silent, you can encode your video in such a way that there's a video track and an audio track. And you can just completely remove the audio track so it's just the video. And you'll make your video like 5 to 8% smaller just by removing the audio stream that no one's going to hear anyway, right? It's sort of like if a tree falls in the wood, does it make a sound? If a video has audio, but no one can hear it, does it matter? Last example, this is still live as far as I know, and it's got so much going on here that it's going to take a second to go through it all. Again, it's a background video. It's loop muted. Preload equals auto. It has a poster. It has two sources. It has an MP4 source and it has a Webm source. The problem here is every single browser, except for Opera Mini, supports MP4. Chromium browsers and Firefox support Webm, but they also support MP4. So no one's ever going to see the Webm. Everyone's just going to get the MP4. So because of the order of the sources, if they ever looked at which videos are being watched from their web page, it's going to be 100% this and 0 Webm. Interestingly, if you look at these two files, actually they're going to have a couple downloads because I've like clicked this URL and played with it because, you know, I muck around with these sorts of things. The MP4 is 73 megabytes and the Webm is 35 megabytes, right? Obviously, they've done some encoding here on the Webm to make it half the size. So 20 megabits per second versus 10 megabits per second. So simply flipping it this way, 77% of the internet, I believe, can support WebM. They just made the web page half the size for a majority of their viewers, just by flipping the two source values. The other thing that's interesting about this is they're hosting all of their videos on S3. S3 is, it's an Amazon storage. It's, it's great. It's awesome. It's really easy and convenient. However, they charge you 9 cents a gigabyte in terms of data transfer, and everyone is downloading a 73 megabyte video. That ends up being like half a penny every single time somebody goes to this web page just to download the video. So if they had just optimized it, right, this one's a quarter of a penny. They could go even smaller. They could make this, 3 megabits per second and still look awesome. And they could, just lower their cost, right? This simple trick lowered my AWS bill by 10x, by 15x. I mean, it's definitely possible just by re-encoding these videos. Use JavaScript to serve the correct video. Only serve one video, like unlike Donald Trump's webpage. If you're autoplaying the video, don't put a placeholder image. Don't use display none. Like, actually just add the source for big screens or remove the source for small screens. Resize your videos. Like, they're big. It's really easy to re-encode videos. If the video is going to be silent on your web page, remove the audio and just order the formats correctly. All of these things will make the video appear faster on your web page. It will stall less often for your customers. It'll just be a better experience using less data and making your web page faster. So the college I went to in Ohio in the States, the background video is a 1080p video, mobile or desktop, right? Because it's just an MP4. It's 5 megabits per second. So if you're at a hotel and you have fast hotel Wi-Fi that's 10 megabits per second, right? This is going to fit through the pipe, right? It's smaller than, it fits in the available network bandwidth, and it's going to show up on my phone. However, maybe you have slow hotel Wi-Fi, right? We've all stayed at hotels where the Wi-Fi isn't all that great. What if you only have 3 megabits per second? The problem here is it's not going to fit down the pipe. So what's going to happen is it's going to take a lot longer for the video to start up. And then even if the video does start up, it's going to play back faster than it can be downloaded, and it's going to stall. And that leads to a bad user experience. Nobody likes the spinny when they're trying to watch a video. So resizing the video, right? Maybe it doesn't need to be 1080p. Maybe it could be smaller. If you think about it, most mobile screens in portrait mode are 1080 pixels, wide. So it's twice as wide as it needs to be. So you could make this, I guess it'd be a quarter of the size if you go by the aspect ratio. It then would fit in this 3 megabit per second, and it would play. Size the video for your end users. Again, responsive video delivery. Can you serve different size videos for different screens? It's not in the video tag by default. You could encode different sizes and insert that with JavaScript. So you could get the size of the screen and then say, for this size screen, insert this source, otherwise insert that source. Or if you don't want video at all for mobile devices, don't insert any source at all, and then you just have an empty video tag and the browser ignores it. The other option that you might have is live streaming or video streaming. And there's two formats of streaming that are out there. There's HTTP live streaming, which has live in the name, but it's used for video on demand. So it's a little confusing. So just call it HLS and it's easier. And then there's Dash. And Dash is the standard format for streaming, but HLS was introduced by Apple, and that's kind of the de facto standard. That's what everybody's using today. So how does video streaming work? Your video is broken into segments or chunks. So you have like a 5-minute video, it's broken into 5 to 10 second segments, and each one of those segments is downloaded to the end user. What makes HLS or Dash even more? So then there's a manifest file. It's a text file that describes, the byte ranges or the files that need to be downloaded for each time frame. It looks something like this, right? So here's your manifest file. The target duration is 10 seconds. Here's the first segment with a byte range in the file, second, third, right? And it might be really long. If it's a lot, it just describes all of the different requests that the player needs to make to play the streaming video. Now, what makes streaming really interesting, and this is what I think about when I think of video streaming, is adaptive bitrate streaming. So you've got this, it's a JavaScript player on the browser now playing the video. And what you can do is you can say, hey, I've got a bunch of different sizes. I've got 360p, I got 720p, I got 1080p, I have 4K, right? You can have 5 or 6 or 8 of these. And you can say, hey, player, you know the size of the screen, download the right one, right? So if it's a mobile device, maybe you get 720p. If it's a really low-end mobile device, maybe 360p. For a bigger screen, maybe 1080p, maybe you have a 4K as well, right? So you have all these different sizes, and the player will decide which one is the right one to download. The other thing the player can do is it can say, oh, I know how fast their network is. So even if you could play a 1080p video, but you can't handle, 4.4 megabits per second, maybe you could handle the 720p. It'll still look pretty good. It'll stream, and it won't stall because the player knows your network speed and can adjust. And it can actually adjust mid-play, right? So maybe you're here and you end up in an area with no coverage. You can drop down to this low one. And then maybe you get to an area with great coverage. It'll bounce back up to here. And so this adaptive bitrate allows the player to change the stream, while the video's playing, right? If you had an MP4 that was 360, an MP4 that was 720, and an MP4 that was 1080p, and you start playing one of them, you're stuck with that one for the whole playback of the video. So how does the player know about these different manifests? There's actually a parent manifest file that describes each one of the available bit rates. And it says, so I've got this one, I got this one, and I got that one. And they all have different, these are the subsequent manifest files. I like to look at it this way. So this is, the player can say, 1.3 megabits per second, 800, or 545 kilobits per second. I know which one is going to play best network speed. These are the codecs that are available, and then the resolution. So the player can balance the yellow and the blue to give the optimal size and bit rate for every single user. So this becomes almost responsive video delivery in that the video can adapt and change depending on the different devices that are being used, and then also if conditions change on the device. And so for me, this is really, if you have a longer video, this is really the way to go. And I would say longer is, over 2 to 3 minutes, right? If you have videos like that, you might want to start talking about doing something that's video streaming in order to really optimize the way that video is being delivered onto the mobile device or onto any device. It's responsive, it's networkware, it's adaptable, and it allows for faster video startup. And the reason it allows for faster video startup, it's a trick. And I'll zoom back here a little bit here. Have you ever watched like a Netflix video and like the first couple seconds looks really choppy and grainy, and then it sharpens up about 4 or 5 seconds in? That's because they're downloading a really low bit rate at the very beginning. Because at 350 kilobits per second, they can download it all and start playing the video very, very quickly. And then as they start downloading, they're like, Doug's on a faster connection, I can give him 720p. Or Doug's on a faster connection, I can give him 1080p. And then it jumps up, and about 4 or 5 seconds in, the video sharpens to a really nice look. And if you think about it, whenever you're watching a movie or a TV show, the first 4 or 5 seconds of it is probably a black screen, or maybe like the beginning of the theme song music, or maybe it's like the 20th Century Fox or something like that, right? It's not something that's integral to the video and you're missing anything by seeing it at 360p. So that's why it starts up faster. Right. So with that, I work for a company that does video streaming. And so if you're interested in checking out how this thing works, we've got APIs that will do this for you. You upload a video it creates the stream for you, and it gives you a player that you can just embed on your web page. So like you kind of understand the theory now, and it's very complicated. It's not really complicated. We all kind of understand how it works. But if you don't want to deal with it, there are a bunch of companies like API.video that will help abstract that from you so you don't have to deal with it, and you can just, host your videos somewhere else. So if you're interested, you should check it out. But with that, I'd like to thank you guys all for listening. And if you have any questions about video, I'd be happy to take them now. If I can stop sharing here.
Thank you so much. That was such a great presentation.
Thank you.
I mean, it felt accessible even as somebody who doesn't have much experience with video. So
good.
Well done. It looks like we do actually have a couple questions. So the first one came in when you were talking about autoplay.
Yeah.
Greg was wondering if it was possible to turn it off completely.
So I think there might be a flag in the browser that you can go in and turn off autoplay. I think if you're on Android and you turn on light mode, it doesn't autoplay videos. I want to go back and check that for sure. And there might be a flag to turn off autoplay. But honestly, you're kind of stuck with it. Unless you turn off, I think you can turn off all videos as a flag. I don't know if you can turn off, you can just turn off autoplay, unfortunately.
Okay. Another question that I had is there an easy way of implementing an image overlay before the videos actually start to play? So when it's in the loading state?
So you can use the poster tag. So there's an attribute right in the video tag that will apply a poster. And that's just a JPEG or, whatever. It'll support any image format that the browser supports. So it'll do a WebP or it'll do a PNG or whatever. So you can definitely have a poster image there. And that's actually really good because, I don't know, you guys have probably uploaded a video to YouTube and like it picks like the frame that shows up and it's usually like, right? It's always, you've got a funny look on your face. You're like, I don't want that to be, what shows up for everything. And you can change that, right? So that's actually YouTube letting you change the thumbnail. But you can also do it with the poster tag. So if you just had like a standard, like for your company's webpage, this is what you want it, this video is coming soon, or, the first frame or something, you can create those for you.
Awesome.
I see a question about the network information API. You can, but the network information API isn't in all the browsers yet. So like that helps you for your Chrome users, but like your Safari and your Firefox users are out of luck with that one. So, your mileage will vary on how successful you are using the network information API.
Cool. We did have a couple of more questions. I can't find it now.
I see one about Webm accelerated encoding for the mobile web. They're all, I don't know. So you can encode videos lots of different ways and you can lower the quality. Just like if you have an image, you can lower the quality and eventually it starts getting all pixelated. You can do the same thing with video. There are a lot of new formats for video that are coming out. I talked about Webm. Webm, there's VP8 format, there's VP9 format, and the new format that's coming out is called AV1. And they're all like 20% smaller. Like it gets 20% smaller every time a new version comes out. AV1 is supported in Chrome today. I think it's behind a flag in Firefox. Like it keeps changing release by release. The one issue I think that there is the encoders for AV1 were really, really slow. So the only people who, could fire up a whole bunch of AWS instances to re-encode their video libraries were places like YouTube and places like Netflix. I believe it's getting faster now, so you can start thinking about using AV1. Again, it's only in a couple browsers right now, but it's coming into more.
Awesome. I think that's all the questions. Thank you for the amazing talk. It was great having you on.
Yeah.
I hope everyone enjoyed that as well. That's not it though. We've got another video coming out from Paul Kinlan, I believe, on stream 1. But that's all from stream 2. We'll put the link to stream 1 in the chat, so feel free to hop over there, and also don't forget to sign up for the prizes. We'll also pop the link in the chat as well. Awesome.
Awesome.
Well, thank you so much.
Thank you very much.
Cool. I guess that's all from us. It was great doing this with you guys. I learned so much today. It's incredible.
Yeah, me too.
Yeah.
Yeah, and it's perfect timing. The next track is about to get started. So thank you guys so much.
Thank you.
Thank you, lads.